The maximum speed of a mass released from rest at point R equals A is equal to, well, we're looking at this and we notice that we are converting gravitational potential energy into kinetic energy. That's fun to do, but how much gravitational potential are we losing? 4 UI. See, you go from 3 to -1, so you're losing 4 U1. Did I say UI? I meant U1. And a lot of people gave an answer of D. The correct answer is E. If you work out the math there, the velocity goes to square root of 8 U1 over M. A lot of people answered D. Looks like they were using 3 U1 instead of 4 U1. Next, simple pendulum makes an angle of theta with the vertical. It's released from rest. The work done by the tension force as the object moves to its lowest point. You might be thinking to yourself, well, we have a change in kinetic energy, so we should have some work done because work is equal to change in kinetic energy. That might be true, but work is equal to Fx delta x, and we have perpendicular. The force is perpendicular to the displacement, so we have no work done by the tension force. How can that be, you ask? How can it be that we have no work done by the tension force? Well, there's work done by gravity. Work done by gravity, yes. Work done by the tension force, not so much. 2 gram. Mass moves in one direction under the influence of a positive dependent force given by F of x is 2x minus 8x cubed. The work done by this force as the object moves from x equals 2 to x equals 1 meter is closest to, well, the equation there is work is equal to the integral of F dr. This is our chance to use the power rule. We remember the power rule. There it is for differentiation. We're integrating here, so let's get to it. And here is the most difficult part of the problem. We are moving from x is equal to 2 meters to x is equal to 1 meter. So you notice my limits there. I got the 1 up top and the 2 on the bottom, the 1 up top, and we are going from 2 to 1. Naturally speaking, you think of going from 1 to 2. I don't like problems like this where it all hinges on a preposition, but hinge it does, and that's what work and energy is all about, and that's what makes it difficult. And we are integrating here. The integral of 2x gives you x squared. The integral of 8x cubed is 2x to the 4th. Yeah, that works out, and then you can plug in 1, you can plug in 2, you can do the work, and you'll get 27 joules. Most people answered with B, negative 27 joules, because I think a lot of people did from 1 to 2 instead of from 2 to 1 because they're crafty. An electric motor provides 0.5 watts of mechanical power. How much time will it take this motor to lift a 0.1 kilogram mass at constant speed from the floor to a shelf 2 meters above the floor? We've got all sorts of quantities here, 3 different quantities. And the reason I'm doing this problem is because I don't like these questions, and I don't think we did a lot of them in class. They're the P equals FV type questions, and the key phrase is constant speed. Key phrase is constant speed. That means by definition acceleration is 0, net force is 0. Net force is 0. We need to figure out the forces on this 0.1 kilogram mass. Weight is equal to mg. I looked, that equation was not, I'm going to put it there, but not on the extra equation sheet. It's such a friendly equation, especially when you use 10 meters per second squared as an approximation for g. We have a 1 Newton downward gravitational force, a 1 Newton upward pulling force that's pulling this thing upward at constant speed, and there you go. Power is equal to force times velocity. Velocity, don't you know, is distance divided by time. The answer is E. Particle of mass 1 kilogram is acted upon by a variable force whose strength is given by the graph below. Above, below. If the particle's speed is 0, what's the speed after 4 meters? Work is equal to the integral of FdR. Work is equal to the area under this force versus distance graph. 1/2 base times height is 10. Length times width is 20. 1/2 base times height is 20. 10 plus 20 plus 20 is 50 is equal to 1/2 mv squared, and that means mass is 1 and velocity is 10 meters per second.